This talk is essentially about sharing with you few techniques like on how to build a valuable, future-proof design system for your product teams in your organization. First, a couple of words about myself. I'm Giamir. I'm a lead product engineer working in the customer experience, product and design service line at Thoughtworks. I'm specialized in UI web technology. I'm also the co-founder of what is today the Thoughtworks Global Frontend community. And I'm really passionate about design system, micro frontends, architecture. This is also what I do like on a daily basis, like consulting our clients like on these topics and writing and speaking about it. So no surprise here that we're here today to talk about design system. This is the agenda like for the day. And as I say, we will get started from defining a design system. So there are several definitions out there like for design systems. Some of them focus on the concrete things, the concrete artifacts like the product teams are actually using, like this one from the Nielsen-Norman group that says that a design system is a set of standards to manage design at scale. And then there are other definitions that they focus more on the process that is involved like, to actually create those artifacts. Like this one from Brad Frost, the author of Atomic Design book, where he says that a design system is the story of how your organization designs and builds digital interfaces. There is no right and wrong definition, but it's important, like, at least for the sake of this talk, to be on the same page when I say design system. I will say design system a lot, so let's make sure that we are all on the same page. So there are essentially two aspects that go into building a design system. There is the product part of the design system that is essentially what it is, reference websites, UI kits, component libraries. Don't worry, we're gonna go into detail in a second about those. Oh, wow. And then there is the operations part. So think about governance, how people work together, the ownership model, how the design system actually get created. So in this talk, I will refer like to design system as just the product parts. But keep in mind that in order to build successful design system, both these aspects, like they actually need to be considered. All right. So what are those design system artifacts that I was talking about? So we have the reference website. This is kind of the business card of your design system. Is essentially a place where perhaps you have a design system vision, you have maybe like a backlog of the items that are under work for the design system. And then we have the parts that are a little bit more technical. So we have the UI kits that are essentially the library of symbols that designers in an organization are using to prototype their interfaces. Right? So think about tools like Sketch, Figma, Adobe XD. So these are libraries that your designer used to prototype the user interfaces. And then we have the technical component libraries. This is what developers use to compose the UI according to the design language. They can do so by leveraging like a set of API that is often documented in dev documentation tools such as Storybook, for example. And depending on what your design system is targeting, you might have different libraries because if in your organization you have teams using different framework, you might have also different component libraries. So, but why your organization and product teams in general want to invest on design system? What are the benefits of design system? Perhaps the most obvious one is that having a design system, it promotes UI consistency and cohesion across all your products. Another benefit is that it makes it easier for team to experiment and actually improve your time to market. It also reduces cognitive load because a lot of decisions regarding how your button in your organization look like, all these UI primitives look like, they've been taken, and the product teams can actually focus on building products, right? So they have more mental capacity for doing that and not taking care of the small things. Design system, they also come generally with higher quality standard because there is more time for thinking about cross-functional requirements such as accessibility, performance, and also making sure perhaps that these components are responsive across different devices. It creates a shared vocabulary in your organization. Think about ubiquitous language that the different teams can use to talk about the UI. And finally, it's also a hub for best practices with regards to visual and interaction design, but also UI development. So despite all those benefits that we have seen, often organizations are struggling to establish valuable design systems for their product teams. And this is because of a variety of reasons. And now I'm gonna just list a few here. It's not a complete list from my personal experience, from what I've seen in several projects that I've been on. So one could be about teams not being able to actually contribute back to the design system, or overly complex processes for changing the design system. And this disincentivizes the team from participating and therefore the design system. Another example that I have is that sometimes design systems are not really a good fit for micro front-end architecture. So if you have a team that needs to deliver a micro front-end that is essentially a UI that can be integrated in an host application, you want this UI to be fully encapsulated. And certain design systems, they're actually implemented in a way where they rely on globally applied style and behavior. And this makes it hard, actually, or impossible, really, for teams building micro front-ends to adopt a design system. Other times, design systems, they might also be outdated, and they could introduce accessibility violation or performance issues. And the last reason that I put in here is that sometimes design systems are trying to be this one-size-fits-all, especially in big organizations. You tend to have a team that is trying to build components that are applicable for all sorts of different applications in your organization. So from B2C type of application to B2E, business to employee, expert-like data-intensive application. And when this happens, unfortunately, teams often end up re-implementing the design language according to their needs because they're just trying to create components that are too generic, right, for everybody for anybody to use. And you already see from this small list that design system can fail also because of how you operate them. So while we will not talk in detail in this talk about the operations part, the design ops part of design system, keep that in mind that it's a crucial factor for success. So what can we do about some of those issues? So we can start from treating design system as any other product. Start from the business goal, understanding what's high priority for your organization. You've seen all these different benefits that the design system could bring to your organization, but what is really the need that the business have? Perhaps You might have some problem like across your different UI with accessibility, and your organization is at risk of being sued or is already being sued. Therefore, you will want to focus on establishing a business goal to achieve a certain accessibility standard across your UIs. So defining a business goal is particularly important because it allows us to explore opportunities and solutions in order to achieve this desired outcome. Then, before jumping into the solution space, it's important to take the time and structure the problem space, understand what the user needs. In the case of design system, the primary user of a design system are developers, product developers, and product designers. You can do that with a variety of product management tools. You can see some of them over here. Today, I want to give you an example using jobs to be done. Jobs to be done is essentially a framework that addresses the question about how you build something that customers want. It's often illustrated by this sentence or this quote that you can see here at the bottom that says, people don't want to buy a drill, they want a hole. So jobs to be done says that people only buy a drill because it helps them to make a hole, but their ultimate goal is to make a hole. There might be other ways actually to creating this hole that don't involve buying a drill. And similarly, product teams, they have some jobs to do, and they won't actually adopt a design system just for the sake of using one. They have some jobs to do, and it's very important to understand what is crucial for them, what are the jobs that they need to do. Some example of these jobs might be rapidly prototype a screen, to test an hypothesis with their end user, or maybe being compliant to a very specific web content accessibility guideline standard, or maybe just being compliant with the latest branding, at all time, of your organization. So understanding the problem space will actually help you to create hypotheses to validate the idea of creating a design system. And if you decided, okay, design system is actually the right tool for the job, make sure to invest the time to capture your assumption onto a hypothesis. You can use an hypothesis template like the one that you're seeing over here. And an hypothesis in a design system context could look like that. We could have as an outcome reducing the time to prototype a new screen for product teams. And it's very important also to set a signal that indicates to us if we are successful or not. In this case, for this hypothesis, it could be the lead time of product teams using the design system being reduced by 20%, where lead time is essentially the time that passes from a task being created and then the work being completed. Another one, a very simple one, could be that as an outcome you want all the product UIs to be updated to the latest branding. And as a signal in this case, you could actually use the time that teams takes to actually update to a new version of a design system, and maybe have that time being below a certain amount of days. All right, so we have now captured our hypothesis. It's time to get our hands dirty. After all, we are at a tech conference, and we're gonna now focus on the code artifact of design system, which are essentially the technical component libraries. How can we build them? So here is a leading question. How do we guide components library implementation towards a desired outcome? And that's where evolutionary architecture can help us. Evolutionary architecture is essentially a way to optimize software for changeability. Evolutionary architecture embraces change because change, it's inevitable. You can see here the cover of the book that our Thoughtworks CTO, Rebecca Parson, Neil Ford, and Pat Kua have wrote a few years back. In there, they define an evolutionary architecture as an architecture that supports incremental guided change as a first principle across multiple dimensions. Where incremental means that evolutionary architecture are done one part at a time in many different increments, supported often by continuous delivery practices. And the guided change part means that evolutionary architecture are able to preserve architecture characteristics that matter to you while the system is evolving. And they can do that by leveraging a concept from genetic algorithms and evolutionary computing that is called fitness function. A fitness function is an objective indication of an architecture characteristic that matters to you. In here, I have a couple of very simple examples of fitness function just to get the grasp of how they could look like. One could be about code quality. We could have a code analysis tool that measures cyclomatic complexity, and then we can have a fitness function that makes sure that there is a specific maximum complexity. Another one, very simple, could be about testing. We're probably all familiar with the test coverage tool, so you could have just a fitness function that makes sure that you have always a specific minimum coverage threshold for your code base. These are very simple atomic fitness functions. There are many different categories of fitness function. We won't have time to cover them. They can be holistic, automatic, manual. So if you are interested on the topic, I will highly recommend you to check out the book, Evolutionary Architecture. But let's go back to our problem at hand. So how can we guide a design system tech architecture? We can do so in 3 steps. First, we can analyze our desired outcome. Then we define architecture characteristic for our component library to preserve this outcome. And finally, we make sure to use fitness function to validate these architecture characteristics that matter to us, to make sure that they don't deteriorate over time. So super simple example about accessibility. Let's imagine that our desired outcome is to make product UI compliant to this very specific web content accessibility guideline. Of course, here the architecture characteristic we want to preserve is accessibility, pretty simple. Maybe the more interesting things is about the fitness function that you can set. You could, for example, create what is called here an accessibility score and make sure that this accessibility score for your design system component, for your technical component library, is always above a certain number, like 95 out of 100, for example. So what's an accessibility score in real life? Unfortunately, accessibility, it's quite hard to automate in terms of testing. So there are tools that provide some sort of audits, like Lighthouse CI or Axe Core, for example, and you should certainly leverage those tools. But your job is not finished there. So you need to make sure to also run manual audits, for example, by just following some web content accessibility guideline checklist to test screen reader, etc., and then combine those two scores into something that you could call an accessibility score. Then you can actually plot how your accessibility score is trending over time and make sure that it stays above your desired threshold. Now, little bit of a disclaimer here. Accessible design system component doesn't mean that automatically all the product UIs will be accessible. That doesn't guarantee that. So it's the first step in the right direction, but it's really important to make sure that you also create this sort of score also at the product UI level. And so from time to time, you actually check that with the actual UI using the design system. The second and last example I have is about brand compliance. We already seen this in one of our hypotheses. We could have as an outcome keeping product UIs updated to the latest trend, to the latest branding, sorry. In here, the architectural characteristic that we might want to preserve is upgradability and stability. We want to make the work of our product team as frictionless as possible, like for them to upgrade. We don't want to introduce extra work, and we should limit, like as much as possible, breaking changes. So we should really double down on stability. Okay, but how do we actually check that these architectural characteristics are preserved? We could, for example, monitor the times that teams takes to update to new version of a design systems. In here, I call this metric design system time to update. And we could have this metric, make sure that this metric stay below a certain number of days. So and if you're using an actual registry to deploy your design system library, you can also fully automate this type of metric. Actually, we did something like that in one of my last projects, and I will show you actually an example of how this metric look like in a second from a real world project. So time to update can be defined as the time interval between the day a new design system version is released and the day when at least 80%, let's say, of downloads are either that version or a newer one, where 80% is just an holistic number and might vary depending on your context. You can plot actually this into a graph like we're doing here and make sure that this time to update for the different versions stay below a threshold. Again, short disclaimer, a short time to update does not guarantee you that all the product UI are compliant to the latest branding. It's certainly though a prerequisite, right? Like because if teams don't even update to the latest version of the design system, you can be almost sure that they are not actually, the UI are not updated to the latest branding. As I promised, here is actually how this time to update metric or KPI like look in a real world project. You can see over there that the fitness function we set that was quite ambitious start to fail for sometimes. And now you may start to wonder, okay, but what do I do when that happens, when the fitness function failed? Don't worry, we will get there in the next and last part of the talk that is about embracing change, making sure that the design system component libraries like are appealing, remain appealing over time for product teams. One issue that I see over and over like across organizations is that they treat design system as a one-off project. There is some budget, you have some people working on it, and then they leave it there. And that's a recipe for, of course, the design system to become obsolete. Products and businesses as well, they actually need to evolve in order to survive. Like we're probably all aware to what happened to Blockbuster, not actually reacting to the technology advancements in the early 2000s. Similarly, Netflix has changed their business model over the years so much. And design system, they need to keep up with the fast-paced technology ecosystem and design ecosystem. We are all aware in the last few decades how JavaScript have changed, like from jQuery to AngularJS. Now we have Angular, Vue, React dominating the market. But what can we expect in 5 years from now? We don't know. So embracing change, like it's probably the right things to do, like evolutionary architecture do. So how change could manifest like in your organization? Here is a super simple example. you might actually have your organization have acquired like another company, and now you have a new business goal that is about making sure that the acquired product UIs are compliant to your brand. So as someone that works in a design system team, like, or you're being close to a design system, you could see an opportunity now to ease the design system integration, like for these new teams and these new UIs. And one solution bound to those opportunities, not the only one, could be about starting to support whatever framework they are using in those UI. So imagine that you have a design system that is built in vanilla web component, and you have binding only for Angular, and this new company that you have acquired, they're using React. So you could decide to invest and say, okay, I'm gonna create bindings also for React to make their life easier. And if you have built your component library following evolutionary architecture concept, you can be sure of evolving your code base with confidence, because evolutionary architecture support change while preserving what matters. So you remember the time to update fitness function that we see a while ago? Imagine that now we are manipulating our code bases to start to support React. So we do some stuff, and then this happens. We start to see the fitness function failing. What does it tell you? In that case, it tells you that the architectural characteristics about upgradability and stability, they are at risk, and consequentially, the outcome about keeping product UIs updated to the latest branding is also at risk. So what do you do in those cases? How do you address a failing fitness function? Well, you have three options. The first one is, of course, do nothing. It's always an option, I suppose. Wait and see, perhaps like, I don't know, in a few days, like the fitness function will go back to normal and everything will work. But most of the time, you really want to take action, like, and perhaps revert what you've done, like on your code base, or maybe change it in a way that the outcome that you are interested to preserve is still preserved. And lastly, a very important one, like fitness function failing can trigger a conversation, like between business and technical leadership about trade-offs. Imagine that now we have more teams starting to adopt the design system. Perhaps the 30 days that we set for ourselves as a time to update metric is a little bit too ambitious, right? So, and the fitness function just need to be adjusted, right? And be a little bit more flexible. Anyway, in all scenarios, fitness function failing, they actually give you an opportunity to proactively, consciously steer the direction of your technical system where you want it to go. All right, to recap, how do we build valuable, future-proof design system for our product teams? We should start from the why, treat our design system as a product, start from defining a business goal, structure the problem space, understand the user needs, and then capture our assumption into hypotheses. Then we can move on into the solution space, where we can leverage evolutionary architecture to steer the technical direction. And we can set up architecture, we can define architecture characteristics that matter to us, like to achieve the initial outcomes that we have, and then use fitness function to guard those characteristics. And finally, get ready to embrace change. Design systems are not a one-off time-limited projects. Like, they need to evolve in order to survive. And you can use evolutionary architecture to adapt them with confidence. So, this is all I have for today. I'm just gonna leave you with a quote from Charles Darwin, because we talk a lot about evolution, reminding us the importance of adapting to change to survive. I wanna say thanks to all the people that have helped me make this talk better, and here you also have some resources that inspire me. And last thanks to all of you for your attention.